You can't just stick a pin in time. Try it. It doesn't work. Nonetheless, geologists need a way of breaking down the history of the Earth into recognizable time units that are both precisely defined and recognizable. It's not a trivial problem, but the answer they've come up with is stratotypes. Last week I did a video on how we date rocks. This was in reality a video about how we correlate rocks, how we tell that things are at the same time from one part of the world to another, and thereby be able to put things into a consistent sequence that we can understand. And after that, we can stick a few numbers on to calibrate it, to actually give us a timescale in millions of years. One thing I neglected to mention, though, is how we actually define these units that we are creating. So the Ordovician, for example, or the stages of the Ordovician, like the Catian or the Hernantian. How do we define them? It's not a trivial problem. We can't just say that such and such is 444 million years old, because we can't date any rock that precisely and certainly. It would be a fuzzy boundary because of the error bars in the dating process, which means that you would never be able to say that you actually were in the Ordovician or the Silurian. If you got 444.1 million years, the error bar might be 3 million years, so you wouldn't know where you were. We just can't use that as a definition. It also means that we can't use things like fossils, because assuming, for example, we define it at the first appearance of Parachaetograptus acuminatus, that's fine maybe for one place, but that species doesn't appear at the same time all around the world. Migration takes a while, colonization of new continents takes a while. So that first appearance will not be correlated from one continent to another. They will be different times. So we can't use that either. Likewise, for any of those other techniques that we have used to correlate from one place to another as far as we can, using all of the tools at our disposal, we can say ultimately that this place is similar to that, but none of those techniques, except event stratigraphy, is perfect enough and precise enough to give us a definition. So what we need for a definition is a single unambiguous point in time, which is precisely, consistently constrained in a way that it can be correlated all over the world. When you think about it, that is not an easy job, because you can't just sort of, as I say, stick a pin in time. It's a little bit too sort of wibbly-wobbly, timey-wimey type. Oh no, that's the other one. Yeah, it's one of these things that you just can't actually get in your hands. So how do we do it? What we need is something that represents time in a physical form. And of course, the thing that represents time in a physical form, if you're a geologist, is rocks. So, a way of getting around this, in very simple terms, is to choose a section, a single location somewhere in the world, which shows the rocks that cross the boundary that you are interested in defining. You then take a metal spike and hammer it into the rock at precisely the point that you want to define. It's called a golden spike, although it's not actually gold, so don't go around pinching them. But these spikes, and there is one for each boundary that has been defined so far, are defined only at that single point. So when we say we're talking about the base of the Silurian, the entire Silurian period is defined between the base of the Silurian and the base of the Devonian above it. So the base of the Silurian is defined at a single point in space, which corresponds to a single point in time. Now that point happens to be in a stream valley in the southern uplands of Scotland called Dobbs Lynn. But others are in China or Argentina or the Czech Republic or the US. There are stratotypes, as we call them, all over the world, which are chosen as the best sites at which we can define those points in time. It's a really simple idea in principle, but in reality, it gets quite complicated trying to apply it. So, for example, let's go to that one at Dobbs Lynn, which is the base of the Silurian. This one has been defined there because partly it was one of the areas that was best known in the early days of the Golden Spikes when these were being first sort of assigned. And so it has been a very well-studied area. It's one of the classic areas of geology. We have a lot of information about the sequences of fossils that we get there. And the environment represented is quite deep water mudstones. So you have a long succession. Actually, it's quite condensed because it's so far out into the ocean at the time it was deposited that you have very little sediment. So a relatively long time period, 1,000,000 years, might be only a meter or two thick. And so what you have there is then a condensed sequence full of marine planktonic fossils. So there are graptolites all the way through, which, as we know, graptolites are wonderful for dating rocks at this point in the geological column. So you have lots of graptolites, which gives you a way of correlating with other areas. There are also other fossils there, things like conodonts and acritarchs, microfossils. You can also dissolve the rock and get some of these out. So that gives you a second layer. There are also volcanic ash beds in the sequence, which allow you to constrain the absolute dating and give you another way of correlating. So how do you pick the exact level that you want to use to define the start of the Silurian for everyone, everywhere, ever? At that point, what you're looking at is something which fits the general ideas which had been quite vague up until that point of when the Silurian should start, so a sort of transition from one set of faunas to another. But you're choosing a precise level, and that level can be defined on the basis of a level that is easy to correlate. So again, we go to the most useful types of correlation system, which in this case is biostratigraphy using graptolites. And we go back to that Parachaetograptus acuminatus, and we say that we will define the base of the Silurian as the first appearance of Parachaetograptus acuminatus at Dobbs Lynn. And then you have a lot of work, people very carefully, systematically logging the graptolite faunas centimetre by centimetre and watching how the faunas change, recording them all, producing logs of where the species all overlap, finding the first appearance of that species and saying, got it. That is where we are going to define the base of the Silurian. It is not defined in millions of years. It is not defined in rock type changes. It is defined only at that point. And that point was chosen because that is the first appearance in this section of that graptolite, which can be used to approximately correlate elsewhere. You need other tools as well to say precisely whether the first appearance of Parachaetograptus acuminatus in, say, Hunan province is the same time as here. It won't be precisely the same time. But that's why we don't define it on that first appearance. We define it at that rock, and then we use the tools that we have to correlate it with other parts around the world. Now, some of you might be asking yourselves why you haven't heard of these things. And it's quite a big thing, isn't it? Having a unit of geological time defined in one place. And you think it would be a source of celebration for the locals. And that kind of depends where you are. So in the UK, we are appallingly bad at celebrating this sort of heritage. To the extent that if you go to Dobbs Lynn, just happen to randomly stumble up a stream valley in the middle of nowhere, you would not know there was anything there at all. There used to be a line of paint on the rock marking the boundary, but that wore off a long time ago. I think Lucy went and saw it when she was doing her PhD, and at that point the paint had virtually worn off. There is nothing there. There's no information board. There's no actual golden spike in the rock. And partly, apparently, this has been a deliberate decision by the conservation bodies to prevent vandalism, which sadly in the UK might actually be a problem. But In other parts of the world, they don't have the same qualms about it. So we've seen several stratotypes over the years, and this is going to turn into a little bit of a travelogue now, including quite a few in China, simply because we spent a lot of time out there working, and it is a celebrated thing in China to have a stratotype. In fact, they have quite a few of the ones in the period that we are working in. So for the Ordovician, they have the base of the Darpingian, the Darawilian, the Hernantian. Several stages of the Ordovician are defined in China. And we've been to all those stratotypes. And they go in for it in quite a big way. Yes, that really is us standing next to a statue of a graptolite. This is in the section, and it is the graptolite in question is Undulograptus ostrodentatus, which marks the base of the Darawilian. So this is one of the stages of the Middle Ordovician, and this is a plaque that is right next to the section, so you can see exactly where the different marker beds are, where the boundary is precisely, with the little golden spike there, and you can see the golden spike in the rock. As I say, not actually gold, but there you go. The little disc of metal there is the marker itself for the base of the Darawilian. And this is defined only here, as with all stratotypes. It is that point, that horizon in the rock. You go sideways and it might sort of disappear, or there might be erosion, you might see a slightly different level. But it is that layer at that point that marks the base of the Darawilian. And they have information plaques. You know, it's quite a nice level of detail. But that's only once you get to the section. So, of course, when you have it as being a large tourist resort, then you have to have a nice sort of ornamented walkway with gateways in traditional sort of Chinese fashion, and bits of topiary along the way and so on. And that's only once you sort of left the car parking area, where the main part of the displays are, including this massive great monolith to the Stratotype. Yes, this is real, and you've got a person for scale there. But there we have a sort of level of celebration of something like this that you would not expect to see anywhere else, really, at least certainly not in the UK. There's also a whole stack of information boards, including information about how the stratotype is chosen, how it's selected, how it's defined, and so on. And they actually celebrate the work of the people whose studies went into this decision. And it's quite a prestigious thing to be included in the recognition of a stratotype. Nice, eh? They even have a rather lovely reconstruction here of the Ordovician, Middle Ordovician seafloor with nautiloids of various types, and there's bound to be some graptolites there somewhere. Maybe we should look a bit closer and
No!
Yeah, understandable. For an explanation of that reaction, see our video on synrhabdosomes. It's a reconstruction that should not exist. Certainly not today in a major new sort of display. But there we go. It is. Anyway, that gives you a bit of a feel for it, and it's not the only one. And there are actually, I think it's 7 stratotypes in China now, and we've also been to see one of their Cambrian ones. The Jiangshanian, which is one of the late Cambrian, stage 9 of the Cambrian, which is why they have there a statue of a huge great number 9. They go into things in quite a big way. They actually build geoparks around them in some cases, where you have a lot of tourism interest in the process of not so much scientific discovery, but the process of science, really, how we actually set up the framework by which we can then do a lot more of the work that is based on it. Because the stratotypes may not be a discovery in any sense, but they are a fundamental foundation for a lot of the rest of paleontology, geology, Earth system science. The entire knowledge that we have of the history of the Earth kind of depends on having a reliable dating system. And it might be pushing it too far to say that these are therefore critical to our understanding of the history of life, But on the other hand, they do give us a framework that we can then work with. So they are important sites, there's no doubt about it. And as opportunities for outreach, for getting people to understand the history of the Earth and deep time and the way that life has changed over these years, it's a wonderful opportunity. And I'd love to see us make more use of it. We actually got to go to the opening of one of them for the Darpingian, which is before the Darwinian. It's another stage of the Ordovician. And there was, it was a thing. It was quite a major event, and you have everything from ladies in local costume to singing to speeches by Communist Party members to, yes, a 6-foot-tall conodont statue. Because the actual conodonts are slightly less impressive, being normally, well, less than a millimetre long. But that conodont is what was used to define the base of the Darpingian, and therefore it gets a statue. And why not? Now we just have to define the base of something on sponges, and we're sorted. But it was a really big event. It was quite spectacular, actually. It was a lovely thing to be able to go and see. And we've been back to the section since, and sadly the upkeep, the removal of weeds and so on off the face has not been keeping up as much as you might hope. But at the time, at least, it was a really major thing. And there are still lots of people who go and visit it, and they still have all the information boards and so on. So it's really worth going to see one of these stratotypes if you happen to have the chance when you're visiting China one day. And then going to see one of these stratotypes in, for example, the UK. So the closest one we had to us, it has since been replaced, unfortunately. So this is no longer a stratotype. But this is Pitch Coppice near Ludlow in the Welsh borders, just probably an hour's journey away from where we are here. And it's deep in the woods. It's an old quarry. And you will see that there is a distinct lack of anything whatsoever. It's one of the Silurian stages, and there is nothing there. Sorry, Silurian substages. It's the Gorstian, which is the first substage of the Ludlow. It's not anymore, so it doesn't matter. But there is no information board, there is no spike, there is no metal plaque in the rock, there is not even a line of paint. The boundary itself was an obvious rock boundary, a lithological boundary, so we could find it easily from the guidebooks, but there is no indication here at all that this was something that was of any importance whatsoever. Which is rather sad, really. And we've got the most incredible heritage, geological heritage in this country, and very little is made of it except as a sort of theme park. I'm thinking things like go and collect ammonites on the Lyme Regis coast and so on. But there's very little which is actually celebrated scientifically. It is in places. I mean, you go to a place like the Natural History Museum and there is a bit there on the British geological heritage. But when you have potentially important sites, or at least sites that are linked to an important part of the science, I think they should have a lot more publicity associated with them. At least public outreach, public understanding of science, that sort of stuff. It's a missed opportunity in my view. So how are these sections and the stratotypes actually chosen? Well, there is a body that is responsible for it. This is the International Commission on Stratigraphy, which is a long-standing major organisation which has a whole series of subcommittees underneath it, who then are composed of specialists on the stratigraphy, the geology, the geological history of a particular time period. So there are half a dozen people, for example, who comprise the subcommission on Ordovician stratigraphy, and there will be others for all of the different periods. And their job is then to assess candidate stratotype sections and points which are proposed by the host countries. Some countries are much more active in proposing their sites, others less so. Depends on how many resources they have and how much expertise they have to be able to put forward a coherent case which is quite compelling that their site is the best one in the world for defining a particular interval. So they have to, over the course of years, sometimes a decade or so, look at all of the candidate sections for each of the intervals that requires a stratotype. That will be the stages, the substages, the base of the period itself, and assess them. It might involve commissioning more work to look at things like the detailed geochemistry through a section. It might require comparative studies on the taxonomy of the things that are in it, fossils, to compare with other places. Lots of honing the data to try to get to an answer as to whether a particular section shows us everything we would want to see to enable easy correlation with other sections around the world. And it is not a purely scientific exercise, because this then has to become the standard for understanding the correlation with the base of an internationally recognized interval. So there is politics involved as well. There is practicality. I know, for example, of one, I think it was a Cambrian section, which was a very, very good candidate on scientific grounds. But the slight problem was that you had to fly to, I think it was Irkutsk, then take a helicopter for about 6 hours or so, where they drop you off with canoes. And then it's something like a day upriver by canoe to get to these outcrops, which were hundreds of miles from any civilization. And that was deemed not suitably accessible for it to become a stratotype. There are also, of course, this being the modern world, problems with actual politics, international politics. So some countries, there are many restrictions on foreign visitors going to them. So I'm thinking North Korea. Iran, unfortunately, has wonderful geology and a lot of good scientists, but there are so many difficulties with international relations. It means that making a stratotype there at the moment is very difficult because people from quite a few countries can't actually go to visit. On the other hand, it could be argued that quite a few Iranian scientists can't go to visit a stratotype that's in, say, America, the US. But this is just part of the sort of stuff that these people have to juggle in order to get to a decision on what is the most practical and scientifically useful stratotype for any particular interval. So it's a long process. It involves a lot of travelling to remote parts of the world and being treated like scientific royalty. And I'm sure there are a lot of perks with doing that job, but it is an awful lot of work. So you can understand why, both why people sign up for that sort of role, and also why it's not just a cushy job. You get quite a lot of resources and travel out of it, but you do have to put in a lot of effort and time. So it's one of these little parts of geology that most people who aren't immersed in the field really don't have any clue that it's happening. They don't realize that this whole field of activity is going on just in order to be able to have the world know what we mean by the Ludlow. It's a strange sort of situation where there's so much going on in the background, which takes a lot of work, and yet it's virtually unknown to most of the world. But, it's the same with any subject. There will be lots of things going on in the background that we don't really know about, unless you happen to be part of it. Anyway, I think that is quite a short one, actually. It's a very short video for me, but I will wrap up there because this was really just to finish off that major loose end from the previous one and get you to understand what golden spikes actually are, because they are basically just a way of sticking a pin into time. So these golden spikes themselves, the stratotype sections and points, or GSSPs as they're known, are our best and currently only viable way of defining accurately, coherently, and in a way that is totally consistent any particular time interval in the geological past. If you can think of a better way of doing it, do tell us, because I don't think anyone else has come up with one yet. Anyway, it works. It's a bit long-winded, and sometimes we have to go back and replace some of the early ones, like pitch copies, sadly. But eventually we will get to a point where all of the intervals that need a stratotype have one, and then hopefully none of them at that point will then need to be changed. But stability is what we want. Anyway, I'll leave it there. Thank you again for listening, and yes, I'll see you again sometime. Ta-ra for now.